Good morning, guys. How are you guys doing? Good morning, one and all present here. We will be just starting in a couple of minutes. Um, let's wait for people to join. Yeah, Nitin, we will be going through the overview of the session when we start. Good morning, one and all present here. My name is Chanakya, and today I am going to be taking the ninth session of DevCamp, which is called Introduction to Machine Learning. Machine learning is an ever growing field, and more people are trying to venture into the field of machine learning. And most of the people try to take up machine learning as the first domain to learn whenever you are venturing into the technical domain. It is also one of the main. It is also one of the main field where people tend to leave it at the earliest because of the complex mathematics that is involved. But I would like to tell you guys that machine learning is not only about mathematics. Even though mathematics constitute, let's say, 50 to 60% of the topic, 50 to 60% of machine learning, but the rest 40% is very interesting to learn. I mean, if you look at the applications of machine learning, that will excite you to build more and more products. Through this course, I would like to clear the basics of machine learning to you guys, because I believe that if the basics of machine learning are clear to you, you can go more deeper into the field, and that will help you in the long run. So let's talking about the overview of the session. We will be first of all talking about what is artificial intelligence and machine learning. And once we are done with that, we will be, so one of the main questions that people usually have in this field is what's the difference between artificial intelligence, machine learning, and deep learning. So I would like to clear that doubt for you, and then we will move on to regression versus classification, and then we will look at different types of machine learning, that is supervised learning, unsupervised learning, and reinforcement learning. Once we are done with that, we will be moving on to some coding part where we will have a look at Numpy and Pandas. And then once we are done with that, you will get a clear hang of the things like how exactly are we supposed to code in machine learning. And then we will be looking at one of the most basic model, and I would say the most interesting one also, that is linear regression. So without wasting much more time, let's dive straight into the session. First of all, let's look at what is artificial intelligence. Usually when I look at certain words, I like to break it down into its subcomponents. That is, artificial intelligence will be broken down into artificial and intelligence. Let's look at the word intelligence first. Intelligence essentially means that you have got the brain, or let's say you have learned a lot of things throughout your life, that you are experienced enough to make a decision on your own. So, and artificial means something which is not human, right? Something which is not living. So in this case, we are talking about computers, or let's say an artificial human being. So what the aim of artificial intelligence is, it are machines that perform tasks those that typically require human intelligence. So let's take the example of self-driving cars. We all have heard about Tesla. Even though Tesla has not, the self-driving cars have not ventured into the Indian market, it is quite dominant in the foreign markets. So when we look at self-driving cars, the first thing which come to our mind is it will help us maneuver through the traffic. So let's say let's say if we are living in cities like Bangalore or Delhi for that matter, traffic is huge, and when we are driving on highways also, we would like the car to be handled on its own, and our indulgence should be decreased. So that is what self-driving cars aim to do. They try to ease your life, and you can watch Netflix, or you can listen to music on your sitting back on your chair and relaxing. And let's also talk about Siri, or let's say Google Home. So earlier times, let's say in 2000s, people would have to, in order to put up an alarm, people usually had to, let's say, open the clock app and then go to and then set an alarm for a particular timing. So now artificial intelligence has made our life much more easier, because we can just give a command that is, hey Siri, or hey Google, please put up an alarm for 8 a.m. in the morning. So that's how artificial intelligence aims to change our lives. Now, the next thing which I would like to talk about is the difference between artificial intelligence, machine learning, and deep learning. This was also one of the main confusion I had when I had started doing artificial intelligence, and I would like to clear that for you guys. So what essentially we have talked about artificial intelligence, that is, it aims to provide intelligence to artificial things. And the next thing which comes into the frame is machine learning. So machine learning essentially means that we are trying to train our machine to perform tasks on our behalf. So let's say we are talking about predicting the price of a home, price of a house. So let's say, imagine yourself, okay, when you want to go and buy a house, there are certain parameters that you would like to take into consideration you make before, let's say, you make an offer for the buyer or tenant for that matter. So you look at the number of bedrooms that are present in the house, you look at the lot area, you look at the number of parking spaces available. So these things that we take into consideration while making a decision, we have to train the machine to do that on our behalf. So that is what essentially machine learning means. It consists of various algorithms that computers can use to make prediction on your behalf. And then the next thing which comes into picture is deep learning. Deep learning, as the name suggests, it's somewhat more advanced than machine learning, and it is a subset of machine learning. Because I say a subset of machine learning because the basic aim of machine learning and deep learning is to make decisions on our behalf. So, but deep learning works in a much more, let's say, complex way. It makes use of something known as artificial neural networks. Let me break artificial neural network down again into three different words. So artificial, you know what it is, and let's talk about neural networks. So there are millions of neurons which are present in our brain, right? With the help of which we can make quick decisions. So what the aim of deep learning is, it aims to provide that brain to the computer so that it can take decision on its own. So let's say while we were children, so we didn't know how to judge the difference between, let's say, a cat and a dog. So our parents used to tell this, right? If you see these features in a particular animal, then it will be a cat, and if you see these particular features in, let's say, a dog, then it will be a dog. So our brain has evolved over time to get to know that, okay, these animals will be cats and these animals will be dogs. So that's what the aim of deep learning is. You should give it let's say a picture. It should be able to classify that picture on its own. That is whether it's a cat or a dog. So that's the basic difference between AI, machine learning, and deep learning. That is, deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. So with the help of these examples, I hope you guys got to know what are the differences between the three. And let's move on to, throughout this course or throughout this session, we will be talking about machine learning as a whole. So machine learning is nothing but, as I said, that it's a subset of artificial intelligence, and it basically it takes decision or on our behalf, and what our aim is, the decision should be precise, basically. I will be talking about how machine learning algorithms tend to take decision on its own. That is how we are able to provide the brain to the computer, going ahead in this course. So now, in order to understand things in a much more clear way, what I will do is I will explain you the difference between traditional programming and machine learning. So let's imagine a case. When we were in our, let's say, first year or in 11th or 12th, we were given certain rules, right? When we had to program something out, we were given things like, okay, if you encounter this particular test case for this particular data, your code should be able to take out that answer. So that is what we used to do in traditional programming. But what machine learning aims to do is, you give it the answers, you give the data. It should be able to calculate the rules on its own. In order to explain this concept in a much more clear way, I would like to take the example of Fibonacci series. So if you guys remember, we used to write code for where we had to judge whether a particular set of numbers follows Fibonacci series or not. So in that case, the basic rule we knew the rule, right, that the sum of the first two numbers should be equal to the third number, and subsequently like that. So we were given the rules, we were given the data, that is the series that we had to judge, and our program should be able to calculate that what is the answer for that, whether that series is following Fibonacci or not. Whereas what machine learning will do is, you give it a series, you give the answer that this series is a Fibonacci series and this series is not a Fibonacci series. So it will automatically calculate the rules on your behalf, and it will basically ease your life in a much more better way. So let's take the example that I was talking about earlier in the session. That is, what if we had to predict the price of a house? So these are the so this is a data set that we have. That data set is nothing but a set of rows and columns. So here you can see that we have a column named price. We have certain features, that is floor space, rooms, lot size, apartment, row house, corner house, detached. So these are the basic features that we take into consideration while predicting the price of a house. So let's say, okay, what we believe is if we have more number of rooms, the price of the house tends to go up. So in order to let computer get to know how to capture this, we will take the concept of machine learning. So what we do is, as I had shown you in the diagram, right? We give the answers, we give the data, and the model tends to return the rules. So in this case also, we will give it the answers. That is, these are the prices corresponding to this particular data. So let's say for number of floor space to be 71, rooms 4, lot size 92, the price is 2,50,000. So in this way, we have given it the answers, we have given the data, and machine learning will automatically calculate the rules for you. Okay, so if let's say if the number of rooms present were greater than a particular amount, then the price would automatically increase. So this is how machine learning essentially works. Uh, Now, the first thing uh, so there are two basic kinds of problems that machine learning tend to solve. Let's say, so those two things are regression and classification. Regression basically means it is used to capture the relationship between, let's say, the dependent variable and the independent variables. So before we move ahead, I would like to tell you what exactly are dependent variables and independent variables. So in this case, as we had discussed, that the price was dependent on these features. So the price will be the dependent variable, and all these features that are floor space, rooms, lot size will be the independent features. So this is what we mean by dependent variables and independent variables. Uh, the next thing, which so now coming back to the regression part, for regression, um, as I said, that we tend to capture the relationship between dependent variable and independent variable. So let's take this example, which is given on the right. So we are given the data that is for $90 of advertisement, we will get $1,000 of sales. For $120, we will get $13 sales. So likewise, the algorithm or the computer should be able to capture the relationship between advertisement and sales, and say for the next time when we give it that, okay, $200 is the advertisement cost, what will be my sales? So this is what essentially regression means. It is used to predict continuous values. What do I mean by continuous? It basically means a set of numerical values. The next problem which we also aim to solve with the help of machine learning is classification. Classification in simple terms means we will categorize the whole data into different classes. So let's say the answer could be yes, just a simple yes, or just a simple no. That is, let's say we take the example of a simple mail classifier. So we have always seen that whenever we receive a spam mail on Gmail, it automatically goes to our spam folder. So that is machine learning for you. It is categorizing the data behind the scenes for you. That is, it splits into spam and non-spam. So uh, that is what classification means. And if I have to give you another example for classification, it basically means, if let's take the example of heart disease classification. So if I give you an image of a heart, is the model able to capture whether you have a problem, the heart has a problem or not? So that is what we essentially mean by classification. Now, before we move on to the basic types of machine learning, I would love to hear it from you guys. That do you guys have any question till now? It can be anything, whether you would like me to explain a particular concept again or have a question. One second. Cool. If you guys have any questions throughout the session, you can feel free to type it out. And I think we had the question that if coronavirus couldn't be predicted by ML, then what's the use of it? See, even though we know the powers of machine learning, but there are certain so it is not always the thing. Machine learning does not always take into consider. It has its own limitations. That is, if we are talking about the cases of corona, right? It machine learning to a particular extent, it has worked its magic where it is able to show people that okay, for this particular area, these many cases will come up. But with the changing, let's say, variants of COVID, this would so the model needs to retrain itself also, right? So in that case, when we have to capture machine learning, doesn't sounds good, but there are a lot of things that goes behind the scenes. Let's say we have to first capture the data, and then we have to work on that particular data set. So those things take time, and that's why there were certain limitations on the application of machine learning in COVID. And I hope that I have answered your question. So now, moving ahead, there are three basic types of machine learning that we do. One is supervised, one is unsupervised, and one is reinforcement learning. So what we essentially means by supervised is we give the computer a set of features as well as the answer to that particular to those particular features. So where we had taken this example, right, where the aim was to sorry, did cool. So coming back to what we were talking about, that is supervised learning. What essentially we do in that case is we are given the features, we are also given the final dependent variable. That is, for a particular set of features, we will be given the price also. That is what we mean by supervised learning. That is, we are given the historical data as well as the answer to those particular features. So that is what we mean by supervised. And the next thing is unsupervised learning. Unsupervised learning, basically, in simple terms, it means that you will not be given the final labels. That is, you will not know what is the price of the house given the features. Or let's say, if we are talking about classification, you won't know what is the end class of that particular data. So let's say, if I'm talking about the example of cats and dogs, you wouldn't know, the computer wouldn't know that okay, this is a cat, this is a dog. It has to learn by itself. That is, what are the features that we have which will essentially classify it as a cat or a dog. In order to explain that in a much more simple way, let's look at this example. So imagine this is the model which we have. As I said, that for supervised learning, you give it the features, you give it the final value. So in this case also, we have given the input data and we have given the annotations. That is, okay, these things are apple, and the model. The next time I give it give it an apple, it will know that it will classify on its own that okay, this is an apple. Whereas in unsupervised learning, what happens is we just give it the input data. That is, you guys can see here. Here we had annotated the data, right? For in case of supervised learning, that is, these are apples. But in this case, for unsupervised learning, what happens is that we just give it the data. We just give the data, and we don't tell the model that okay, this is an apple, this is a banana. So the model has to learn on its own. Okay, if I see these features, that is, if the shape of, let's say, let's say if it sees something of red color and round shape, it will be a banana. So that is what the basic difference, or that's the basic difference between supervised and unsupervised learning. Now the next thing, so yeah, this is another example that I wanted to tell you guys. That is, here you can see, this is the left part shows the supervised learning and the right part shows the unsupervised learning. So now here for supervised learning, we had the data as well as the final label that we wanted it to have. So here, the red class basically represents a particular the red class basically represents a particular class, and the blue color represents another class. So here the model will know, okay, if let's say a point that is a data point comes to the left of this line, it will be belonging to the red class, and if a data point comes to the right of this line, it will be belonging to the blue class. Whereas in unsupervised learning, what happens is that so here you can see we don't know which points belong to which color. So here we knew that, okay, these data points had red label and these data points had blue label. But for unsupervised learning, you can see everything is gray. So the model has to learn on itself. Okay, so here you can see that these points are very near to each other. So these will belong to one class. Whereas these points are very close to each other, so this will form another class. So in this way, the model tends to capture the relationship between the data points. So this is the basic difference between supervised and unsupervised learning. Now, yeah. So now it's a quiz time for you guys. I have a question for you, that is, which of the following are examples of supervised machine learning tasks? A, credit card fraud detection, B, digits recognizer, C, predicting the unhappy customers, or D, all of the above. Feel free to type in your answer in the comment section, and I would love to hear from you guys. Come on, guys. This should be an easy one for you. So meanwhile, I get to know the answers of you guys. There is a doubt that how can we see if we need to implement supervised or unsupervised by looking at the data set. So that's a great question. Let me go back to the house price prediction data set that we had earlier. So in this case, what happened was, you knew, right? My ultimate aim was I needed to predict the price of a house. So I knew that out of all these particular features, the price would be the final dependent variable, and all the other things will be independent variables. So with the help of that, I got to know that this is a supervised learning task, because I knew that I needed to predict price, and I had all the features. So this is how you got to know that this is a supervised learning task, uh, by by knowing that what is your end result. Whereas if you see for unsupervised learning, there would not be a fixed dependent variable which will be given to you. That is, you will have only the features and not the final class. Like I said, that you will only know that these are the images of apples. Actually, you will not know these are the images of apples. You will just know that these are some fruits. The model has to capture on its own how what are the relationship or the patterns that it has observed. So this is how you can differentiate between a supervised learning and an unsupervised learning task. So coming back to I hope I was able to answer your doubt. So let's see what other people have answered. Yeah. So someone has said that means in supervised learning we will have output from beginning, right? Yeah, we will be having output from beginning. Like I said, that we had the price available with us. So that's correct. And rest of the people have pretty much answered correct. That is, the answer should be D, all of the above, because for digits recognizer we will be given the image as well as the digit which it represents. For credit card fraud detection, we will be given certain let's say features. and then we will also be given whether it was a fraud transaction or not. And let's say for predicting the unhappy customers, the data set will again be labeled in the form of 0 or 1. That is, these particular customers are happy and these are not. So the correct answer was D. Kudos to you guys for giving the correct answer. And yeah, the next question which I have for you guys is, which of the following are examples of unsupervised machine learning tasks? A, customer segmentation; B, clustering; and C, classifying a picture as a dog or a cat; or D, A and B. Feel free to type in your answer in the chat box. Mohit, we are talking about unsupervised machine learning tasks. Let's wait for certain more answers, then I will explain. So yeah, let's move on. The correct answer to this question is D. That is both customer segmentation and clustering. So now, classifying a picture as a dog or a cat is a supervised learning task because we will be given the image of we will be given an image as well as what the image represents. That is whether it was a dog or a cat. So that's why the answer is A and B. And I think one person had asked what is clustering. Great question. Let me answer that. So what clustering means is it will basically organize the whole data set into a set of clusters. So let's take this example again. The diagram on the right side, that is unsupervised learning. Here you can see that it has formed two clusters for you. Clusters are nothing in real world. It also means a group, right? So here also it will try to form a group of similar data points. That is what is essentially meant by unsupervised learning. Because here you can see it has formed a couple of clusters for you. So I hope I was able to answer that doubt. If you have continuation of that doubt, feel free to ask in the chat box. And so yeah, the last type of machine learning task that we usually do is reinforcement learning. Out of all the three types of machine learning that we have, I can guarantee that reinforcement learning is the most interesting one. We have seen the cases where, let's say, where we have seen that certain robots are able to defeat human beings in a particular game. Let's say there was a deep mind uh, developed something called as AlphaGo, which could beat human beings in the game in Go game. So what essentially happens in reinforcement learning is that let me give you an example. So let's say that we are playing a particular game, and our end aim of any game is that we need to the end goal of any game is to win that, right? Let's say we are playing what do you call the snakes game. We would not want our snake to die at the end, right? So that is what reinforcement learning essentially does. It will get to know that what our end goal is, that is whether we want to maximize, whether we want to be alive at the game or not. And in between, it will basically reward itself by doing certain actions. So imagine yourself playing a game. You know that if I move left and then move right and then move left, it would reward me, or it would give me a lot of rewards. That is, I will get positive rewards or a hell lot of rewards. But let's say if you performed a certain move which did not benefit you, that is, it decreased the reward or you are dead by the end. So the agent or the model will get to know, okay, that in this case these steps were good steps, that is, it rewarded the most and I am alive at the end of the game, and these were very bad steps and I did not remain alive at the end. So in order to give you a good example of certain examples of reinforcement learning, what I will do is, let's go to a site called OpenAI Gym. There you will get to see a lot of interesting examples. Uh, yep, let me share my screen again. 1 second. So yeah, meanwhile, before we continue, I would encourage you guys to go to this link, that is gym.openai.com. I will paste it. Okay, thank you, Nidhi, for letting us know. We will try to sort that out. 1 second. Yeah, before we move on, do feel free to tell me how is the session going. Do you want me to slow down, or do you want me to increase my speed? Uh, I would love to change it for you guys. So till now we have talked about supervised, unsupervised learning, and in the start, when I had started doing machine learning, it was difficult for me to also get the difference between the two, because uh, it was very difficult for me to differentiate as well, because for a data set, many a times you won't know what is your end goal. So that comes with practice. So if right now, if you are feeling that, okay, I'm not able to get these basic differences also, that's completely fine, because you guys are getting started right now. And what I would suggest is try to read up more cases, more let's say examples of supervised and unsupervised, so that you know that, okay, these are the things that are supervised, and these are unsupervised. So now let's move ahead. So let me just give a very quick recap about reinforcement learning. Reinforcement learning is uh, nothing but the agent trying to maximize the reward, that is play the game on behalf of the computer. So let's so yeah, I will be sharing that link in like 1 minute, because yeah, let me share that link with you. Yeah, so I hope that you have got the link. We feel free to go to that link, because it's very interesting. I will show it to you right now also. So here, let's go to the environments part. So here you can see that let's take this example, cart pole example. So here the main aim of cart pole is that this pendulum which we have, that is present on the cart. So this should ultimately so here you can see that a pole is attached by an unactuated joint to a cart. So it need to learn how to balance itself. So here you can see we have certain episodes. What we essentially mean by episode is the trial. So for the first trial, what was the end result? For the second trial, what was the end result? So here you can see, as the number of trials increases, the cart pole has learned how to balance that particular stick. So let's take another example which will make things more interesting. So here you can see. So this is another interesting example which I personally like, because here you can see the problem in hand is that we have to make this pendulum basically swing up. That is, it should ultimately go swing right to the top and be stable. So here you can see, for the first trial, the pendulum used to fall down, and then again come down. But as the number of trials had increased, the pendulum had learned how to go right till the top. So these are essentially examples of reinforcement learning, because here we have just the agent is trying to learn things on its own, like how to balance itself, like how to take the pendulum right to the top. So this is what essentially we mean by reinforcement learning, and hope with the help of this particular link you were able to get your have a basic hang of reinforcement learning. So now the next thing which we are going to explore is the Python libraries for ML. Before we move on to that, do you guys have any doubt? Feel free to type in the chat box and let me know. Cool. So we have a question that didn't understand reinforcement learning. So what essentially reinforcement learning do is, I would, so imagine yourself playing a game, right? That is a very basic example that I can think of. So imagine yourself playing a game, and whenever we play a game, our end result is to win that game. Right? So in order to win the games, we already know that these are certain steps that we need to perform, which will, let's say, keep me alive at the end, or let's say I will ultimately win. So now, in order to let the agent know that, or let's say let the artificial human being to know that how to play that game, that is what essentially reinforcement learning is for. So it will, so we again train the model, we follow certain steps to let the agent or the artificial computer know that this is how you are supposed to play this game. So that is what is essentially meant by reinforcement learning. Things are a little bit complicated when we talk about reinforcement learning. So right now, if just understand what exactly it is and what are the certain applications that we have, because this particular field is explored at last when we are doing AI, because it involves certain complex mathematical steps, as well as it's difficult to implement. So right now, just get a gist of what exactly we mean by reinforcement learning. And talking about the next question, that is, what was the GYM Open API for? So let me open that again, OpenAI GYM. So what it basically means, so whenever we talk about reinforcement learning, right, there are certain basic games, or let's say environment where you can test your model on. So that is what OpenAI GYM provides you. So let's say if I take this example where here you can see, right, the bot has to learn to land in between these two poles. So in order to so let's say you have come up with your own model and you want to test it out now. So OpenAI GYM provides you that environment to test out your model. So you can get to know how is my model working in this case, whether it's performing good or whether it's performing bad. So it's basically an experimentation platform which allows you to basically test your reinforcement learning models. I hope I have answered the questions which you guys had. If we don't have any other question, we can move on. Let's move on. So now it's where the basic fun part begins. That is, we are going to code some basic things out. That we are now going to explore the different Python libraries that we have for ML. So the first library which I would like to talk about is Numpy. I'm sure a lot of you have heard about Numpy, what exactly its role is. So just to explain it in brief, it is a statistical library, or let's say a linear algebra library for Python, where you can perform certain operations that, let's say if you are talking about multiplying two arrays, right? If we were just talking about lists, you would have to make a for loop, or let's say perform certain other steps that will enable you to perform multiplication. But what Numpy does is it makes your life easier. It makes statistics easy for you. It makes implementing the statistical concepts easy for you, and it is very fast. I mean, it's incredibly fast to implement. And now we will be moving on to the coding part, where we will code out NumPy, the basic operations of NumPy. So I would encourage you guys to go to the link, open Collab. I will explain it to you what exactly Collab does and why do we use Collab. I will also share this Collab link on in the chat section so that you can open it. So give a thumbs up if you are at Collab right now. Or for that matter, you can just go to Google and search for Collab. It will automatically take you to Google Collab. So so now let me explain it to you guys. So are we all on the same page? That is, whether you are present on Collab. Great. Ayush is there. What about others? For now, the data set which we will be using, I will share it with you. Right now, we are just going to look at the basic operations of NumPy because, as I had said in the starting, that we need the basics. We need to clear out our basic concepts. So once we are done with that, when we are implementing linear regression, we will be sharing the dataset link with you so that we can implement linear regression together. So now let me explain it to you what exactly Collab is. Collab is a data science tool that that makes your life easier. As you can see on the screen, that it provides you free access to the GPUs, which is GPUs is nothing but let's say it makes your computation much more faster. It stands for graphical processing unit. It's a way lot faster than CPU. And it also, the Collab also allows you to share your code with other people so that, let's say you encounter a problem, others can solve it for you. So now what we will do is we will create a new notebook, and you can go to the file and then press new notebook. So now here you can see that we have opened a new notebook. We have a new notebook in front of us. So right now you might be wondering, why is it blank? How notebooks function is that we have a certain number of cells. So this particular thing is a cell which we have, and we can execute this cell to get to know the output basically. So let's say, first of all, I would like you guys to click the connect button, because connect. So how Collab works is that it will make you connect to a machine which is working behind the scenes, and it will create an instance for you basically. So in order to make it work, you need to first connect to that instance. So that's the technical details of working of Collab. Don't worry about that. So now let's say you wanted to print hello world. So in order to execute, there are two options which you have. One is either you can press this run button which you can see. So you get the output, or you can press shift enter. So that will automatically execute for you and then move on to create a new cell. So now let's dive straight into NumPy. So in order to explain you the difference between NumPy and list, because you might be wondering that what is the use of NumPy when we have lists with us. Lists are basically in Python represented by square brackets, right? Where we have 1, 2, 3. So this is a list. So now, whereas NumPy also helps you to create an array of elements, but what it exactly does is the speed and the memory, the speed of operations increases, as well. The speed of the operation decreases, and let's say the memory of storing those elements also decreases. So let's take an example where I will show you guys what the speed aspect of NumPy and list. So here you can see that for list, we are first declaring couple of arrays. with the length as 1000. And then with NumPy, we are also creating two NumPy arrays, which will ultimately we are creating two NumPy arrays. And then what we are doing is we aim to add these two arrays together. So here you can see z is equal to xi plus yi for I in range length x, which is basically plus operation. And for NumPy, we have certain things called, we can directly add the two arrays together. So now if I run this particular cell, first, see, you will get the error name NumPy is not defined. So in order to import, in order to let NumPy be present in your environment, what you need to do is import NumPy as NP. So now the NumPy has been imported, and if you execute this, you will see NumPy in this example is 6.9% faster. This is a huge number when we are just talking about the addition. What if we are talking about, let's say, cases where the complexity or the computation is huge? So in that case, you will get to know that NumPy is actually much more faster than let's say lists. So now let's move into declaring a NumPy array. So I would like you guys to follow along. So what we will do is my list will be, first let's declare a normal array 1, 2, normal list. So this is my list, and in order to print this list, I can just simply type in this thing. We get 1, 2, 3. Now let's say I want to convert it into a NumPy array. So there is a command which is called as NumPy np dot array my list. So here you can see, so now you can see that initially it was a list. Now it has been converted to a NumPy array. So now let's declare it with variable. We will call it as NumPy list is equal to NumPy.array my list. So in order to print the NumPy list, I will again, so here you can see we got an array of 1, 2, 3. Now the next thing which we can also create 2D arrays for, let's say, matrix with the help of NumPy. So what we do is we will again use, let me define it with a variable, matrix is equal to NumPy.array. So again, let's see, I want the first row to be basically 1, 2, 3, and then the next row to be 4, 5, 6, and maybe the next row to be 7, 8, 9. So now if I execute this, and then if I print it, you will be able to see that we got a 2D array with us. So let's say now you want to check what are the shapes of basically what are the shapes of this 2D matrix. It basically means that what are the number of rows and number of columns present. So in order to do that, we have a command which is called as matrix.shape. So here you can see that it returned 3, 3. That is, initially when we declared 3 rows and 3 columns, right? So dot shape also returned 3 rows and 3 columns for us. The next thing which we can also talk about is indexing part. So let me get back the list which I have initially declared, that is my list. So if I print this out, and now let's say you want to access the second element of this particular list, what you usually do in Python is you just write my list 1. So it will automatically print number 2 for you. But in NumPy for NumPy also it's the same. What we can do is we can use NumPy list. So NumPy list was the NumPy array we had, and we can just we can enter the same index. Sorry. So here you can see that we got 2. So this is the same indexing as what happens in the list. And after that, we can also talk about selection part. So let's say for the initial NumPy list, we had these elements, right? 1, 2, 3. Let me increase the range of this particular, that is, increase the number of elements present in NumPy list. Let me redefine it. NumPy list is equal to, so now let's say you wanted to include 1 to 10 in a particular list, in a particular NumPy array. So what you can do is you can just type numpy.arange 10. So what this essentially means is that you are telling NumPy to create a NumPy array for you, which will contain all the elements from 0 to 10. So if I execute this and if I print out NumPy list, here you can see that we have got all the elements from 0 to 9. Because when we when we declare a number x for numpy.arange, it will create the elements from 0 to that number minus 1. Now, I would also like you guys to focus on appreciate the fact that NumPy provides you with intuitive commands. Because let's say I wanted to declare a NumPy array, I can just do NumPy.array. Now, if I wanted to, let's say, define a range for a particular list, I can use NumPy.arange. So all these commands are very easy to understand and very intuitive to remember also. And that's the beauty of NumPy which we have. So now let's say we have got this NumPy list from 0 to 9. What if I wanted to return all those elements which are, let's say, less than 4? So what I will do is I will just do NumPy list less than 4. So now you can see that it has returned an array of true and false. So let's see why it has returned true. Here you can see as 0 was less than 4, it returned true, and as 5 was greater than 4, it returned false. But now you might be wondering that what will I do with these true and false? I wanted the actual list which contains those elements less than 4. So what I will do is I will just enclose this command with square brackets, and then I will just re-enter the name. Because so now if I print enter, I will you can see that I got back those elements which are actually less than 4 and not true and false. So what what essentially is happening behind the scenes is this particular thing will return the index where the elements are actually true, that is 0, 1, 2, 3, and then it will just, the NumPy and the square bracket will just enable it to print those elements with those index. So that's how it works behind the scenes. But now I had a certain list with me, right? This was 1, 2, 3 was a list which we had. Now you might be wondering, can we do the same with the list? So let me try that. My list is less than 2. Because I had only three elements, I'm just decreasing the number. So what do you guys think? What will be the output of this? Will it get executed or it will return an error? Feel free to test it out on your local environment and tell me the result. Okay, Jeevan is saying it will return an error. Let's see what happens. Come on, guys, what about other people? So what do you guys think? Will it return an error or will it get executed and return all those elements which are less than 2? Okay, let me reveal the answer by running this particular cell. So here, you can see it returned an error. So great job, Jeevan, on answering that correctly. So yeah, great. Yashasvi has also answered correctly. So here you can see that it has actually returned an error because this particular operation is not, the less than operator is not supported between a list and a number. So this is how, now I hope that you get to know the difference between list and NumPy arrays. NumPy arrays allow you to do a lot more than lists. And let me give you another example where actually NumPy is much more powerful than list. So let's say you declare a list with 1, 2, 3 and another list with 1, 4, 5, 6. So now if I do A plus B, what do you guys think will be the output? Will it get concatenated, like B will be concatenated at the end of A, or the element wise addition will happen? Yeah, feel free to drop in the answer for this question in the chat box. So there is a question that what does NumPy list less than 4 mean? So NumPy list less than 4, so the task in hand was I wanted all those elements which the elements of this particular numpy array which were less than 4. So in order to get to know what are the elements which are less than 4, I have used this particular command, that is numpy list is less than 4. So I will get to know at which indexes the number is actually less than 4, and then we can move ahead with the next command which we had already discussed, that is we enclose it within square brackets, and then we will get to know the actual elements which are less than 4. So now, coming back to the original question, what do you think will be the answer of this? Will it perform concatenation, or will it perform addition? Yeah, great. Ayush has said concatenate at the end of A. Let's check that by executing this thing again. So yeah, that's absolutely correct, Ayush. This thing has particularly concatenated B at the end of A. So now, whereas what if I had done this numpy.array, sorry, not one, A, and then again B is equal to numpy.array B. So now what I have done is I have converted the element type from, sorry, not the element type, the object type from list to numpy array. And now let's do A plus B. Sorry, not A plus B. So now if I execute this, you will see that element wise addition has happened. So 1 plus 4 was 5, 2 plus 5 7, and 3 plus 6 9. So here you got to know another big advantage of using numpy instead of arrays, because in the field of, let's say, anything that involves maths, you would not obviously want this one thing to be concatenated at the end of another. You would like the two lists to be added, or let's say certain operations performed element wise. So let's say now you wanted to take element wise multiplication. So you do A star B, you get the element wise multiplication of the result of the elements. So this is also one of the main advantages of using numpy instead of list. And now let's say you wanted to take the square root of each element present in the numpy array. So numpy provides you the option of doing that also. What you can do is numpy.sqrt and then just enter the numpy array. And if I execute this, you will see I got the square root of each of the element. So here initially our A was 1, 2, 3, right? So the square root of 1 is 1, square root of 2 is 1.4, and for 3 it's 1.73. So here I'm sure you have you are starting to appreciate numpy and the power of numpy, basically, because it essentially makes your life much easier than lists, because for performing lists you would have to create a for loop, or let's say use another inefficient method, I would say. Numpy, whereas you can just do what you normally do in your real life. You want multiplication, numpy will do it for you. You want square root of each element, numpy has that option also. So that's the power of numpy. So these were the basic operations of numpy that I wanted to talk about. If you guys have any doubt in numpy, feel free to ask. If you have no doubt, you can type it out as well, so that I get to know that I am teaching well. Cool. I will take that as a no. So you guys have no doubt. So if you have any other doubt in between, feel free to ask. So the next thing which we are going to talk about is pandas. Oh no, not this pandas we are talking about. We are talking about the Python one, right? So yeah. So now we have the pandas library with us. So now, if you remember in the starting, we had talked about dealing with certain data frames, right? What if we have a data frame with us and we want to, let's say, do certain data frame manipulation or data frame analysis, or let's say we want to basically analyze our data frame. So what we do in that case is we use Pandas. So Pandas is a very powerful and fast, flexible, easy to use open source data frame analysis tool, and it is used a lot in our day-to-day machine learning journey. So I will also be teaching you guys certain operations of Pandas. So the first thing which we will look at in Pandas is let's create a markdown first to differentiate between NumPy and Pandas. So now we will be moving on to the Pandas part. So now the first thing which we talk about in Pandas is series. What essentially a series means is, let me first show it to you guys what we mean by a series. So let's define a series first. pd.series data is equal to 1, 2, 3, and let's just execute this for now. Okay, this is invalid syntax because I missed out a closing square bracket. Oh yeah, again, PD is not defined. So guys, please remember to import Pandas or any library which we are using before executing anything. So right now here you can see we have a series with us. So here what essentially it is showing is, for element 1 the index is 0. For element 2 we have cool. So I hope that the YouTube thing has been sorted out and we can move ahead. So yeah, now coming back. So I will, in order to let you guys, so initially we had a data frame right with us that we had this data frame with us, and let's say we wanted to get a list of the D and E column. So here you have got it, DF, D and E. So now let's say you wanted to select. So let me reprint the data frame in hand. So this is the data frame we had in hand, and now we wanted to, let's say, access only the first row. So what you can do is, so as I had said that the first row is indicated by A. So what I can do is df.loc. So what loc essentially means is locate. So df.locate the Ath row. So now if I execute this, I will get 1, 2, 3 with column names as DEF. So this is the power. So again, we must appreciate how easy it is to, the commands are very intuitive. Like if you want certain columns, you can just specify the index number. And if you want, let's say, only a particular row, you can also you can access it with the row name. So now let's say, let me get back the data frame with me. So here we have the original data frame with us. And now let's say I wanted to create a new column whose elements are basically the sum of D and the Eth column. So what it essentially means is I will have a new column G whose elements are sum of the elements of D and E. That is 1 plus 2, 3, 4 plus 5, 9, and 7 plus 8, 15. So what I can do is, and this part is also very, very easy. You just define a new column that is DFG is equal to DF of column A plus DF of column, oh, sorry, not A, sorry. A is not a valid column name. I will have to say D and DF of E. So let me execute this. And then again, let me show DF. So here you can see I have got a new column which is G, with whose elements are basically the sum of the D and the E column. So 1 plus 2, 3, 4 plus 5, 9, and likewise for 7 and 8. So this is how we can create a new column for let's say this we can create a new column with the specified conditions which we have in hand. So now you know what, I don't I don't require the G column. So what I will need to do is I will need to drop this particular column from the data frame. And what I can do is I will use df.drop command. Again, this particular command is also very intuitive. You can just think, okay, now I need to drop something. There is the command name is also drop. Isn't that very easy to understand? And what I will do is df.drop G column. I have to specify the column name. And then after that, what I need to do is I have to specify something known as axis. Because let's say if I just had executed this command, it will return G not found in axis, because by default data frames are dealt row wise. So right now the axis has been set to row. So if I would have specified A, you would have seen that the A row has been like removed. But in order to remove a column, I need to specify axis is equal to 1. So here, if I execute, you will see that the dth column has been removed. But now let me again bring up the df data frame which we had. See here, the dth column is still present, whereas we had removed it in the previous step. So now, in order to permanently delete a particular column, we have to specify a command which is in place is equal to true. So again, this is also very intuitive, because in place basically means something permanent. By default, this permanent thing was set to false. If I change it to true, that column would have been dropped anyway. So if I execute this and then again bring up df, you can see dth column has been removed permanently. So that is how we actually these are some of the basic operations that we wanted to know about pandas, and I hope you guys have got a basic understanding of NumPy and Pandas, the working and the basic operations which we have discussed about. And if you have any doubt, feel free to ask in the chat box. I will wait for a couple of minutes. Meanwhile, you guys can attempt this quiz, which the question which is being shown on the screen. How can we create a NumPy array storing numbers from 1 to 10? Come on, guys. I have already included this in the basic operations that we had talked about. So do tell me, what do you feel is the correct answer for this? Okay, so Ayush have said B. Let's see if that's correct or not. Okay, Jeevan is saying D and Sai is saying numpy.arange 10. Let's see if that is correct. What's the D option? Yep. So the question was, how can we create a NumPy array storing numbers from 1 to 10? The correct answer would be D, none of the above. Because the reason is, the first thing is we want to store numbers from 1. NumPy.arange by default stores the number from 0. So that's one thing we need to keep in mind. And if you want to change the starting number, there is an inbuilt argument which is known as start. So what you do is you specify the start and the end, so it will automatically create that list for you. So this was a tricky question, and that's why I would suggest you guys to explore the documentation part of NumPy, because That's very important. So the correct answer for this was D. Great job, Jeevan, on answering that correct. So the next question which I have for you guys is this question: which of the following pandas command will display the last 5 rows of a data frame? What do you guys think? What will be the answer for this? Okay, Sai has said C, df.ilog -5. Okay. So now, just to add a bit, we had seen df.loc command, right? Where I wanted to access, if I wanted to access the A row, I would say df.locate A. But what if I wanted to access with the help of only the index? Df also allows me to do that. What I can do is df.ilog. So locate with the help of integer. So I will say df.ilog 0. You can see it will return the same thing. So LOC is basically used when we have an alphabetical index or the row name, and ILOC is used when we want to access it with the help of an integer, basically. So yeah, what do you guys think will be the answer for this? Do take into consideration the intuitive part of pandas. Like, if I wanted to solve this particular question without knowing anything, the first thing which I would see is, okay, which of the option makes most sense. So df.tail 5. So I want to see the last 5 rows, and it is all, so tail basically means end, and it has entered 5. So this might be a correct answer. If I want to see df.head 5, so head is basically the first head basically means the top, right? So head 5 basically means the top 5 rows. This will not be a correct answer because I want the last 5 rows. And now this is the thing. This is the part where things get interesting. Df.ilog -5 till end. So what this essentially do is, first of all, this will be wrong, right? Because I have told you guys that LOC is useful when we want to do it with an integer. So I can't do it with -5 for LOC. So D and B are completely out of the scenes. For C, df.ilog -5 to end. So if you know basics of Python, when we mention semicolon at the end and use minus sign with it, it will essentially take, let's say, it will essentially go to the end of the data frame and then take the last 5. So in this case, many of you have answered given the answer as A. So df.tail 5 is absolutely correct. Kudos to you guys for answering that. But C is also a correct answer because ilog will basically you tell pandas that you are going to locate with the help of integers, and then -5 will tell you, okay, the last 5 rows, and semicolon means till the end. So you are telling pandas that, okay, pandas, you give me the last 5 rows of this data frame with the help of ilog. So the correct answer would have been A and C. So kudos to you guys for answering any of the correct option. So yeah, do you guys have any other doubt in hand? If not, we can move on. We can dive straight into ML now. Before we dive straight into ML, so if we are going to be dealing with a particular data set, and I will be sharing the data set link right now. It's a Google Drive link. You can go and download the data set which is present at this particular link. Cool. So if you guys have any doubt, feel free to ask anytime during the session. So the next thing which we are going to look at is we are going to look at linear regression, which is one of the basic models that we deal, that one of the most easy and most interesting model to understand. So what essentially linear regression means is it aims to capture the relationship between the independent variable and the dependent variable. So if we focus on this particular line, on this particular diagram which we have, so here you can see that we have a set of data points in hand. What we need to do is we need to find a linear fit to this particular line. That is, find the equation of this line, which will, so you give it the value x, it should find the value y. In order to make things more clear, you guys must be remembering that back in school, or let's say in first year, we had encountered equation which is called y is equal to let's say mx plus c. So what we essentially do during what we essentially did during that period was we took certain values of x, we got y. We took another value of x, we got another y, and then we would usually plot out that line on a graph. So that was what we used in let's say grade 11th and 12th. So now what linear regression essentially will do is it will try to, so in that case also we had to estimate the value of m and c, right? Basically the intercept value and the slope value. So what we did there was we put in one value of x and one value of y, and for the second equation also we will put in one value of x and one value of y, and then we would easily get d0 and d1, like the usual way we solve a linear equation. But so that is the aim of machine linear regression also. With the help of given data points, it has to estimate what are the values of b0 and b1. So that is what essentially machine learning do. As I had told you guys, we give it the answer, we give it the data. So in this case, we give it the y, we give it the x. So now it has to learn by itself how to calculate the values of b0 and b1. So I hope that you guys have understood what exactly are we talking about here. We have to find out b0 and b1 given y and x. In order to make things much more clearer, here is the case where where things would get much more easier to understand. So initially, let's leave out this red line, okay, for now. Just imagine that you have these data points with you, and you need to find a right fit to these data points, such as such as the machine learning model is very precise. So let's wait. So here at this particular instant, you will see that this is the perfect line. But initially what it did was it took a random line and then it tried to improve itself to get to the optimal line. Because here you can see now you must have observed that initially it was not nowhere nearer to any of the data points. It was very far away from the data points. But with time, it learned that this is the right fit, and so how essentially this is working is, I will give, in order to explain things in a much more clear, what I will do is I will take a screenshot at the initial point which we had. So here, so now let me show it to you guys. So see this. Here, this was the initial case which we had. These were the data points in hand, and this was the linear line that machine learning model had learned. But in this case, you can see that this is a very bad fit to these lines, because for this particular x, let's take this example. For this particular value of x, originally the value should have been this. Like for minus 2.9, the value should have been minus 350, let's say. But our model is predicting that value should have been minus 250. Isn't this a very bad model? And so we can conclude that this is right now at this particular moment, the model is not a good fit. And how do we know it is not a good fit? By analyzing this error graph. Now, let me explain it to you. What exactly do I mean by error? So as I had already talked about, for minus 3.5, the original value was minus 350. But we predicted it to be minus 250. Now, in order to get to know how bad my result was, I will take the vertical difference between the two, that is the difference between the predicted value and the actual value. And similarly for other data points also. So for each of these data points, I will calculate this distance, I will calculate vertical distance, and similarly add all of these things together to get a cumulative error. that has been plotted here basically. Here initially the error was very high when we had seen the case where we had randomly fit a line, right? This red line was something like this. It was present here. So at that point of time, the error was huge. But with time, what happened was it had learned how to basically decrease the error, and now you can see that it from 16,000, it has decreased to, let's say, 2,000. So with time, machine learning model had learned that okay, this was not a good fit. This was a good fit, and at the end you can see. Let's come back to the original GIF. This is the perfect line, and the error was very close to zero. So in this way, basically, we try to let the model know that by calculating the error that okay, this is a good fit, this is a bad fit. Uh, and you can see the error has certainly decreased from 16,000 to let's say zero. Let's take another example. Initially, again, the what do you say? The line was fitted randomly, like it was very far away from the data points. But with time, this red line ultimately got closer and closer to the original data points, and you can see that a parabola has been formed, and the error has decreased from 1800 to, let's say, close to zero. So isn't this very intuitive to understand? I mean, with the help of these GIFs, I'm sure you would have gotten a better idea of of what we are exactly talking about. And if you guys have any doubt, feel free to ask. But now the real question is, how do we estimate the parameters? Like, we got to know that we have an error. The ultimate motive is to calculate what are B0 and B1, but how exactly do we calculate the coefficients? So before we move on to that part, I want you guys to understand what is ordinary least square. If you guys remember that I have talked about the vertical distance between the predicted value and the actual value. So here in this particular graph, the black dots represent the original data points, and the blue line represents what the model has predicted. So I have told you that we calculate the vertical distance between the predicted value and the actual value, and then we sum it across the whole data set, like across all the points, to get a final value. So let's take this example. So our initial aim was to calculate B0 and B1. And after that, let's say you have calculated a certain B0 and B1, and you have gotten a predicted value. That is this blue point. Sorry, not the blue point, the red point. But the original value should have been 7, and you have gotten it as 4. So what you do is you calculate this vertical distance, and similarly calculate it for all the data points present. Let's say the difference was 0.5. Here it was 3. Here it is 1. Here it is 2. And here it is 1. So we square each of these differences and add them. So let's say at the end of, by going through the whole data set, the error value which we got was 10. So in that case, it will be the error value for those particular parameters. That is, for B0 and B1, we have gotten the error to be 10. So now our aim should be for the next B0 and B1 that we estimate, that particular error should decrease. So that is what we essentially mean by this ordinary least square, where our aim is to minimize the squared difference between the predicted value and the actual value. So now now you might be wondering that, okay, I understood. This is what I have to minimize. I understood that there is a hypothesis in hand, that is y is equal to beta naught plus beta 1x, and I need to calculate the parameters, that is what are B0 and B1. And I also know that how do I evaluate the error, that is the word I need to find the difference between the predicted value and the actual value, and then I square it, and then I add it across from 1 to m. That is, I calculate this value for the whole data set. So now what our goal, as I had said, that my aim should be to decrease the error in hand. So that is what we are trying to do here, minimize j of theta naught theta 1, which is nothing that minimize the error. So this is what our basic aim is. Now we need to find theta naught and theta 1 in order to minimize this particular error. So that is where gradient descent comes into picture. Gradient descent, let me explain it to you with the help of an example. Imagine yourself standing on a hill, and your aim is to go to the bottom of the hill. So how would you get to know that, okay, if I go in this direction, I will be going down the slope, and if I go in in the upward direction, I will be moving away from my initial aim. So in that case, what we usually do is we calculate the slope, right? So let's say if you were standing at this particular data point, this thing, if and your aim was to go to the hill bottom, that is at the yellow point. So what you would do is you would calculate the slope, that is the angle which that particular line makes with the x-axis. So in this case, you would get to know that, okay, with the help of slope, if I go in this direction by, so let's say if your slope was positive, right? So you would get to know that, okay, in this direction, I will be going down the hill, and in the opposite direction, I would going up the hill. So that's what we are trying to now come back to our original case. We want to go down the hill so that we attain a minimum value. Uh, so initially, let's say you were present, as I had told you, that the line get fitted by taking randomized values, right? In this particular diagram, this thing. So if we see this diagram, initially it was the parameters were randomized, and for that particular randomization, the error was very high. So we were present at this point, that is here, randomized initial value. Now my aim is to go down the hill, that is reach the minimum. So in that case, what I will be now, let's go back to the mountains only. Let's say you want to reach to the bottom of the sorry, let me yeah, sorry for the interruption. So now let's say you were present at this particular point on the hill, and let's say you go down the hill with a speed of 100 km per hour. Do you think that you will be able to stop at the hilltop, sorry, at the hill bottom without overshooting that point? Like you go down with very fast speed, and you will not stop at the minimum, but you will overshoot the minimum and go back to the top. And also take the scenario like where you walk very slow. So in that case, your speed of attaining the minimum will be very slow, and so that's what we call as learning, select a right learning rate. That is how, at what speed should I go down the hill so that neither I am very slow nor I overshoot, like I don't go to the very top of the hill again. So that is what we mean by learning rate. And this is the overall algorithm of gradient descent. That is, the new parameter will be the initial parameter minus how fast should I go down the slope. That is represented by alpha. And then I differentiate it with respect to the parameters. That is, I calculate the slope. So in that way, I will show you with an example. So here you can see, initially I had this red line. I was present at the hilltop, but I wanted to go down the hill to the bottom. So here you can see the red point is going to the bottom, and then it has attained the minimum. Uh, so that's how gradient descent essentially works. Like you are at the top, you go down to the bottom, and then you will get, the moment you reach the bottom, right, you will get the right parameters. So that's what we mean by, that's how basically linear regression works. And now we will be moving on to the fun part, that is implementing linear regression. Before we move on to that, if you guys have any doubt, feel free to ask. Cool. I will take that as a no. So what we can do now is, we had shared a dataset link with you, right? So I will also be performing the same step which you guys can perform. So we will first go to this particular link. Um, I will download this dataset. So you guys can also. Yep. So sorry, I don't know what happened. One second. Yep. Is my screen visible? Like I don't know. Something happened. Yep. I think we are back live. So sorry for the interruption caused. So what I was saying is, let's go to the link which I had shared with you guys, the Google Drive link, and I already have that installed with me. So what I will do is let me straight away go to Collab. So sorry for the interruption caused. So what I was saying is. So yeah, let us continue working on the same notebook that we had created earlier. So the first thing which I need you guys to do is bring the data set into the environment. So this is the data set that I had shared with you guys. That is e-commerce customers. What you can do is you can drag and drop the data set into the file folder of this particular collab link. So this is the file folder. You can see now that my data set is visible. So we can get started with the implementation part. So again, the first thing is let's import the basic libraries that we will be requiring. Import pandas as PD, and after that, as is not. So yeah, the basic libraries have been imported, and we have this data set with us. So now, in order to bring that data set into an environment, we will be using pd.read CSV. So CSV is a kind of file which stores the data, that is comma separated value, and there are, in order to read an Excel file, there is an option called pd.read Excel also. Feel free to use that in the future. And let me mention the name of the data set, that is e-commerce customers, and let me print out how exactly the data set looks. So yeah, here is the data set in hand. So let's analyze this data set. We have email with us, we have address with us, we have avatar with us, and then we have certain parameters like average session length, time on app, time on website, length of membership, and we have to predict what is the yearly amount spent. That is, this data set is talking about how much the user will spend on a particular app given these particular features, like what is the average session length the user has spent, what is the time he has spent on app, and what is the length of the membership if he or she has bought it. So in that, using these features, we have to predict the yearly amount spent. So now, in order to make things simpler for this session, what we will do is we will remove the columns email, address, and avatar, because these are textual data, and we will maybe talk about the textual data in the upcoming sessions. But for now, let us remove these columns. So what you can do is I will use df.drop. Let us specify. If you guys remember what I have told in the basic operations, you guys can go ahead and implementing on your own. Let's say I drop email, I have to drop address, I have to drop avatar. Now again, I have to specify that I am dealing with the columns, that is access is equal to 1, and do remember to use in place is equal to true, because I have already mentioned the reason for that. And if I check out the df data frame again, you can see I have the email, address, and the avatar section have been removed, and I am only left with these particular features. And so now let us separate this whole data frame into x and y. That is, x will represent the features and y will represent the value to be predicted. So x will be equal to df. I don't need the yearly spent amount. I just need the first 4 columns. So what I can do is I will use df.drop, only drop the yearly spent amount, but I don't want this to be permanent. Like this should not be deleted from the initial data frame that we had. So what I will do is x is equal to 1, but I will not be using in place is equal to true, and y will be equal to df of yearly amount spent. And if I I will execute this and then maybe show X. So here you can see that we don't have the yearly amount spent column, and for Y, we have the value to be predicted. So this is how we will separate into features and value to be predicted. Now let's begin to code out the ML part. So now before we move on to the coding this out, what I can do is I will have to separate the whole data set into two different data frames. That is the train set and the test set. The reason for doing that is, let's say that you have trained your model on this whole data set. That is, you have taken the whole 500 rows into consideration and got particular values for got B0 and B1. But now what if you wanted to test that model out? You don't have any data left out in hand. Where will you go and test out that model? So and the basic aim of machine learning is that your model should be generalized enough to work in any scenario. It shouldn't be that, okay, this model have not seen such cases, so it will perform poorly. That's not how machine learning works. So what you would need, that's why we split it into train and test data set. What we will do is, from sklearn dot model selection import train test split. So again, the command is very intuitive. That is, split the whole data frame into train and test, and then we will just do x train, x test, y train, y test is equal to train test split. We have to split what? We have to first split x, then split y, and what is the split ratio? Like how much percentage of the data should be present for the test data set and how much should be present for train data set. So what we do is we specify something known as test size. That is, test size is equal to 0.2, and then we just press enter. Now if I go and check what is the shape of x train, you can see for x train we have 400 rows, and for, let's see, x test. So for x test we have 100 rows. So our aim so now we will train our linear regression model on x train and then evaluate on x test. So what we will do is, let's start building the model. sklearn dot linear model is import linear regression, and then we will declare the object linear regression, and then what we will do is lr dot fit. Again, as I had talked about, that we need to find the right parameters, right? So I will have to fit it on the train data set in hand, and then so here we have specified the data as well as the final answer. Now the linear regression will find out the coefficients on its own. So in order to view the coefficients, what you do is you do lr.coef. So now you can see that we had 4 variables initially, that is average session length, time on app, time on website. The linear regression have found out the right coefficients. Like for the first variable, it is 25 into that variable plus 38 into the second variable plus so it has basically found out the relationship between each of these independent variable and the dependent variable. So this is how we have trained our model. Now what if we wanted to make certain predictions? So what we do is we use predictions is equal to lr.predict x test. If you guys remember the right reason for splitting the data set, the reason was to basically make the model generalized enough, right? So now I'm testing it on the test data set in hand. So lr.predict x test. Now if I go and print out the predictions, you can see I have the predictions in hand. Now let's say you might be wondering that, okay, we have fitted the data set, we have predicted new values. How do we know that our model is good or bad? So for that, we have certain evaluation metrics in hand. Let me open the slides. 1 second, 10 minutes. Yep. So let's go to the slides. Here you. 1 second. So yeah, here you can see that we define certain evaluation metrics in hand. So we have certain predictions, and now if you remember correctly, what I have told was that I need to find the difference between the actual value and the predicted value. So that is what we term as error. So there are three different types of error that you can calculate. One is mean absolute error, one is mean squared error, and one is root mean squared error. So mean absolute error is nothing but the absolute difference between the original values and the predicted values. And mean squared error is just squaring that term. So let us test that out. So sklearn is such a powerful library that it provides you with the inbuilt methods only. What you can do is from sklearn dot matrix import import mean absolute error. If we have to calculate mean squared error, there is option for that as well. So we have imported mean absolute error and mean squared error, and now I can just print out the values. Let's say I want to know what is the mean absolute error of my model. So mean absolute error, first I have to specify the original data that I had, and then I will specify what is the predictions that I have made. So here you can see the error is 8.10. So this is essentially how we build a particular model and evaluate it, like how is it performing, whether it's good or bad. So this is how we do linear regression, and I hope that you have understood the theory behind also. In order to just summarize it, what we do is we have data set, we pick out certain columns from the data set, and then we initialize our model. Then we split it into train and test data set in hand. After that, we just fit the model on train because we need the model to be generalized enough. Once that is done, we can make predictions with that. So this is essentially how this is a very basic pipeline that we are talking about right now. And as you go deeper into the field, the things get complicated enough, and that is for you to explore. So with that, I would like to end my session. I hope you guys learned a lot throughout the session, and if you guys have any other doubt, feel free to ask right now. I will be staying back for 2-3 minutes. Okay, I would like to take that as a no. If you guys have any other doubt, feel free to contact us at GDSC. You can contact us through social media platforms, and we would love to answer your doubts. So with that, I would like to end my session. Thank you guys for joining. Hope you guys have had fun. Bye bye.